Okay, so this video serves as an introduction to the mole. The mole is a unit that gets used in chemistry to stand in for talking about very large numbers of particles. Um, Atoms and molecules and ions are really, really tiny. In fact, they're so tiny and there's so many of them that we can't possibly count them. It's truly impossible to count them all the time. So instead, there is a consistent large number of them that we use and refer to and think of when we discuss how much of a substance we're using. We'll use this in chemical equations, and we use it just when we're talking about a given amount of a substance. To help this kind of make sense, I find it helpful to start with an analogy of something that people are familiar with that are much larger than atoms and molecules, but still quite small. So if you think about candy, and you think about a candy like M&Ms, even something as big as an M&M would be really difficult to count if you were running a candy shop. They're so small that if you actually had to count individual M&Ms out whenever you sold them, whenever you bought more, it would just take you way too much time. It would not be a practical way to deal with counting how much candy you were buying or selling. So, candy makers long ago have come up with a solution to this, which is to bag up a certain amount of candy. And so, you should assume, or I think everyone assumes, when they buy a bag of candy, that every time they buy a bag of candy, it pretty much has exactly the same number of M&Ms in it, give or take a couple, but close enough that it's fine, that it can be considered to have a consistent number of M&Ms. So a bag is just a way of simplifying counting of very small pieces of candy. So if we make up a number and say that one bag of M&Ms holds 600 M&M pieces, then we no longer have to count individual M&Ms. If I have a bag of M&Ms, I'm going to assume it holds 600 pieces. And if I have 10 bags, then I'll assume I have 6,000 pieces. And so I can much more quickly figure out how many pieces of candy I have by bagging them up in a consistent way. Now, even simpler than that, or even better than that, really, is that since every bag holds the same number of pieces of candy, it should always weigh the same. So if we make up a number here and say that our bag of 600 M&Ms hold is exactly 500 grams of mass, then for every 500 grams, we know that's equivalent to a bag, and we know that's equivalent to 600 pieces of candy. So now we have an extra tool, which is that we can weigh our candy and immediately figure out how many bags that is equivalent to, and also how many pieces are in that sample just based on the mass. So this is a way of counting without actually having to do the counting because the counting would take way too long. So this is the type of question that comes up a lot on paper one, the multiple choice question, and it's the question that you can't do with a calculator. So I've given you the value here for 600 in scientific notation for a reason. That's typically how the numbers associated with moles will appear because they're so large. And so we have to get familiar with using scientific notation and moving around decimal places. The good news is that the math on paper one is relatively simple, so long as you can use scientific notation. Okay, so key idea here is that mass, bags, and pieces of candy are really just three different ways of expressing the same amount. So, if one bag of candy weighs 500 grams and holds 600 pieces, then if we have two bags of candy, we should pretty quickly realize that that holds twice as many pieces of candy. So, 1,200 pieces of candy, which is 1.2 times 10 to the 3 pieces of candy. And we should know that if one bag weighs 500 grams, then two bags weighs 1,000 grams. Right? So it should be pretty simple to convert between these things. We should see that when we start with the bags, when I want to know the number of grams, I'm multiplying by what the bag weighs. So I did 2 times 500. And when I went to the number of pieces of candy, I also multiplied. I did 2 times the number of pieces in the bag. So 2 times 600 gave me 1,200. Okay. Now, if I start with 5,000 grams, as the mass, if I want to know how many bags I have to divide by the number of grams in a bag. So there's 500 grams in a bag. 5,000 divided by 500 gets me 10 bags. And if I have 10 bags, then when I go from bags to another unit, I end up multiplying. There's 10 times the 600 pieces is going to give me 6,000 pieces. So a couple of things here. Notice that if we start out with mass, we really don't go directly to the number of pieces of candy. I guess you could, um, but usually it's kind of a two-step question. First, you go from the mass of candy, and we can figure out how many bags that is pretty simply. And once we know the number of bags, then we can also figure out the number of pieces of candy if we want to. When I converted into bags, I divided. And when I convert out of bags, I always multiply. Here's one more example. If I start with 1.2 times 10 to the fourth, I can undo the scientific notation if I want, in this case. So that gives me 12,000 pieces of candy. There's 600 in each. Put this here. So I'm going to end up with a 2. The 12 divided by the 6 is a 2. And then I believe, if I do this right, I'll end up with 20 bags of candy. Let's see. Is that right? Yeah, that's right. 20 bags of candy. Okay. And then if I want to know the mass, again, if I'm going out from bags, I'm always going to multiply. So 20 times 500, that gives me 10,000 grams of candy. So we can do these conversions in all directions. If we start with mass, it's one step to get to bags, it's another step to get to pieces. And if I start with particles or pieces, I can do one step to the bags and then another step to get to the mass. Okay. Now, that's kind of a simple example. That's when we're talking about candy. And we should see, if I skip on down, it's really going to be the same thing when we're talking about moles. So with moles, it's just that the number is much, much larger. But I used that number 600 on purpose because when we deal with moles, the number of particles in a mole is consistent, just like I made up in my example. The number of pieces in a bag is always the same. So in 1 mole of anything, there are 6.0 times 10 to the 23rd things. So that's the number of particles in 1 mole. Now, it's just like having a bag. Okay, so it's always going to represent that number of things, and we'll talk about where that number comes from in class. But for now, how do we use that in a calculation? Well, if I have 2 moles of oxygen atoms, how many actual oxygen atoms does that represent? Well, if 1 mole represents 6 times 10 to the 23rd, then if I multiply that times 2, I will get 12 times 10 to the 23rd. Now that's not really proper scientific notation, so we would move the decimal place 1 over on the 12. We'd get 1.2 times 10 to the 24th. I made the 12 look 1 decimal place smaller, so I have to make the exponent on the 10 one exponent larger. So having 2 moles just means you have twice as many particles as if you had 1 mole. And if 1 mole is 6 times 10 to the 23rd, times it by 2, you get 12 times 10 to the 23rd. It's kind of as simple as that. It's just like with the bags and the pieces of candy. And then the same thing goes for mass. I'm starting with moles. There's a particular mass for every element. It's on the periodic table. It's the same number as its atomic mass. So for oxygen, its molar mass is 16 grams per mole. That's how we write it in the IB. 16 grams times moles to the -1 is the same as per mole. Well, if that's how much 1 mole weighs, and we have 2 moles, then we're going to have 32 grams of oxygen. So just like with the candy bags, if you have 2 bags, then you're going to have twice as many grams as if you had 1 bag. You're going to have twice as many pieces as if you had 1 bag. So you're just multiplying. We can also then practice if we start out with grams, and if we start out with pieces, we can figure out the number of moles, and we can figure out the number of particles. But that's basically it. That's the idea of the mole. The mole is just a large number of particles. It's a very, very large number of particles. 6 times 10 to the 23rd is an absolutely enormous number, which we'll talk about in class. But really, it's a way of talking about how much matter we have, how many particles we have, with saving us the trouble of trying to count them, because it's truly impossible. So when we talk about and compare amounts of substances, we'll say, well, I've got 1 mole of this and I've got 2 moles of that, and that's going to react with 3 moles of this. Rather than talking about individual atoms and molecules, we're going to talk about the amounts of substances in terms of how many moles we have. And so converting between grams and moles and particles is sort of a fundamental skill for the class.